Good morning and welcome to the academic training lectures in IT. Before I start the introduction, I would like to remind you of how the lectures will work. First, the speaker, Eric, will deliver the lecture, followed by a question and answer slot at the end. You can ask questions via chat, I will read them, or raise your hand via Zoom and I will give you your turn, okay? So then, here in IT at CERN, we have a solid network infrastructure, as you know, for moving data around, for transferring all our knowledge, not just for physics, but for all fields in which we collaborate on a daily basis. That is why we wanted to include a network series this time that will help us learn and understand all of the current network technologies, both hardware and software. We will learn them from the hands of 5 outstanding speakers who were carefully selected in collaboration with the IT network team. So thank you, Tony and Eduardo. I hope you are there, probably yes. And today I'm delighted to introduce you the first speaker, Eric Hauser. I hope I'm pronouncing it properly, Hauser. He is the CEO for GIANT, the Europe's leading collaboration on internet and services for research and education. Before that, he was CTO of Arpanet and the Dutch National Academic and Research Network. I'm not going to go through all his outstanding CV, but for over 30 years, he has been involved in education and research networking. That is why he's providing this lecture today, but also internet standardization and internet governance. For his contributions to the internet, he has been inducted into the Internet Hall of Fame in 2014, and in 2015 he was honored with the title of Dutch ICT Personality of the Year. He has been teaching at various developing countries workshops on internet policy and technology, and he is a TED speaker. So that is why I'm totally sure that we are going to enjoy a lot this lecture today. So please join me to welcome Eric Hauser.
Thank you, Maria, for that introduction. Before I start my slides, I'll start with a short anecdote that ties me into CERN. In 1992, I was chairing an IETF working group. IETF Internet Engineering Task Force is the body that sets standards for the internet, and I was chairing a working group that was looking at a common interface to databases. At that point in time, the internet was fully ASCII based, so only letters on the screen, no graphics, and several libraries started to add their indexes to the internet, but all with a different interface. So we were tasked to define a common interface, and we were looking at a protocol called Gopher. And we had a meeting in Zurich in '92, and I was chairing that meeting, and at the start of the meeting, this guy from CERN comes up to me and he says, "Hello, I'm Tim Berners-Lee, and I have an alternative for Gopher, and it's called the World Wide Web. Can I show that to the working group?" And I said, "Well, sure, it's an open working group. You can show it." So Tim showed us an ASCII version of the World Wide Web, and we were suitably unimpressed. In fact, we didn't think very much of it. I myself also thought, well, you know, I don't see the advantage over Gopher. Gopher is much better with metadata. And the only thing we really liked was the URL. So I said to Tim, let's work together and standardize the URL, which we did. But we also, at Tim's, was very persistent that we would also standardize HTML and HTTP. And the rest is history, I guess. But it shows you that I'm very bad at predicting the future, and my lecture is going to look at the past of research and education networks, the present of research and education networks in Europe, and the future of research and education networks. So let me start my slides. There you go. You should be able to see my slides as well as myself, I hope, at the same time.
Perfect.
Good. So let me first start with a little bit of history. In the 70s, there was no real organized research and education networking. There were mostly ad hoc arrangements between some universities or some groups within a university. In the 80s, we saw a little bit of integration of initiatives. It wasn't happening very fast as at that time to get anything between locations in the form of leased lines was really expensive. So modems were used using the telephone network, operating at 300 bits per second. And also in the 80s, we saw the start of supercomputing centers for research, which would be a major driving force between in the 90s for the advent of research and education networks. By the end of the 80s, we saw in various countries the start of the first networks for research and education. In Europe, those were mostly X25 based, which was an OSI protocol that was very popular at that time. In the US, they were NCP and UUCP based. And by the early 90s, capacity has grown from the 300 bits per second to 8 megabits per second, which was a pretty significant growth. And then the first services started to be developed to support researchers: terminal access, called Telnet, file transfer, FTP, and email. And the trick at that time was that most of the users were very knowledgeable. They had a lot of computing skills. So it was mostly users developing services they were using themselves, which is always a pretty good key to making working solutions, of course. The telecom monopolies at that time did see little economic reasons for developing services specific for research and education. The market was just too small. So I'll speed up a little bit. So we had pre-1990 various disconnected networks based on OSI protocols, DECnet protocols, UCP, IBM protocols. And gradually, around that time, we saw two European initiatives pop up. One was called EARN, the European Academic Research Network based on IBM protocols, and the other one was RARE, Réseau Associé de la Recherche Européen, which was more a mixture of protocols. And then we had, of course, the European Unix network that was not only dedicated to research. There was other entities on there, but certainly several universities used that. In 1990, there was a meeting in Ireland, in Killarney, that was chaired by Brian Carpenter, who was at that point in time, I think, head of IT at CERN, and myself. And Brian and I managed to get two things done. One is that RARE and EARN were merged into one organization called TERENA, Trans-European Research and Education Network. And we also managed to end a protocol war. Up to then, there was a protocol war between people supporting connection-oriented protocols, the ones that telecom industry had been using historically, and the people who were promoting connection-less protocols. In 1990 in Killarney, we put everybody in one room and we closed the doors, and Brian and I said we wouldn't be leaving until we had a decision which one it would be. Fortunately, we chose connection-less, which led to the adoption of Internet Protocol, which is a connection-less protocol. And therefore we are now stuck with the internet. If we had chosen connection-oriented, I have no clue what would have happened, but we might still be stuck with X25 at this point in time. Later in the 90s, the academic networking was recognized by the European Commission. Some money was reserved to support research in Europe on an international scale. And a network called Arpanet was built, a multi-protocol service network, which was run by a new organization based in Cambridge called Dante. This Arpanet evolved into a trans-European network of 34 megabits per second later in the 90s, and by the end of the 90s into 155 megabit per second network. In 2000, the European Commission commissioned the GN1 project, GN1, for a GN network service. Again, GN at that time stood for Gigabit European Academic Network. This was followed up by a GN2 project, which expanded the network even further, increased speeds, but started to add all kinds of services aimed at research and network and education on top of that. And in 2009, the third instantiation was there. And by that time, we had built a network. This is the GN2 network that run through most of Europe in a fashion with small loops to avoid any break of service if one of the links wouldn't work. So you would always have the other one. And as you can see, the coverage of Europe was becoming quite extensive. 38 countries were participating. At the core in Northwestern Europe, we had the first dark fiber links because there was enough competition there to bring the prices down. In the southern and eastern part of Europe, there was little competition, more monopolies, and therefore dark fiber was unaffordable. And at that time, under the GN project, we started to build the links from Europe to the rest of the world, to Southeast Asia, India, Africa, and North America, and through North America to South America. We worked there together with local projects in those regions. So in South America, there was the Red Clara topology was built under the Alice project. Around the Mediterranean, we worked with UMedConnect to build a network in the North African and Southern European countries. And in Southeast Asia, we worked with 10-3 topology to build a network out in that region. And then in 2014, there was a lot of pressure from outside on Terena and Dante. Terena was, to remind you, the party that was established in 1992. And Dante was established in a year later to start the Arpanet. So Dante was a more operational organization. Terena was a more innovation and development, turned into a more innovation, development and community organization. And in 2014, there was a lot of pressure from the European Commission as well as from the individual member states to merge the two into one organization. And we did that, and that organization was called GN, the same name as the projects that we were running at the time. And so from 2014 onwards, we had one organization for European education and research networking, connecting all the national research and education networks together and delivering services to them. And that was called GEON. We did this in, it's a small anecdote. The way we did this was, Dante was actually a non-profit limited company in the UK, and 100% of the shares of that company were given to Terena, and then Terena's name was changed into GEON, and therefore Terena owned 100% of Dante, and that was a very simple way to merge the two organizations. In 2015, we requested KPMG to give an advice whether we should do away with the limited or not, and turn it into one real merged organization or not. And KPMG said, you can do that, but it will cost you roughly 800,000 euros to do so in taxes, lawyers, accountants, but mainly taxes to dissolve the limited organization. So early 2016, the General Assembly of GEON decided that was not worthwhile, because we didn't want to spend 800,000 euro on just doing away with the formality of the limited organization. In June 2016, of course, or was it June, well, later 2016, the British people decided differently. They voted for Brexit, and that immediately made the whole situation totally different, because if the UK left the EU, which eventually happened, Dante would be in a the former Dante part, so the limited would be in a non-EU country and could no longer be financed with EU subsidies. So eventually, gradually, we did do away with the limited, and made the staff in Cambridge in the UK staff of a Dutch entity, because the Terena headquarters is established in Amsterdam. So GEON is now an Amsterdam-based organization with a branch in the UK, and that works. This is the timeline, by the way, that you will see in our offices, whether you go to Cambridge or Amsterdam. You'll see this painted on the wall. Currently, we have 40 members, one per country, all over Europe. Our articles say that every country can only have one national research and education network that is a member of GEON. As you can see, we range all the way from Belgium to the Nordics, from Malta to Cyprus, even Turkey and Israel are a member, and also on the eastern part of Europe, Azerbaijan is a member, Armenia is a member, Belarus is still a member, although you can imagine that requires some discussion at this point in time. Georgia is a member as well, Moldova is a member, Ukraine, of course, is a member. Russia is not a member. Here you can see it in an easier way, and as you can see, we have a blind spot here in the Balkan. That's Bosnia and Kosovo. Kosovo is not a recognized country by the United Nations, and our articles say only networks can become a member if they're from a recognized country by the United Nations. And Bosnia doesn't have a research and education network yet, but we're working on that. Together with the World Bank, we have a project to build a research and education network in Bosnia. And going to the present, this is what we're currently working on. This network is almost finished. And if you look at this network, you'll see that we cover quite a lot now with fiber. It's either fiber, that's the black, or it's spectrum that we have, which is the yellow. Spectrum we usually get from a deal with the National Research and Education Networks, which makes our network very cost efficient. And as you can see, we still have the rings, but in a more clever way. And because we have spectrum and fiber, we are now much more flexible in the services we deliver at the network level. The Scandinavian countries are served by Nordunet, which also built a new fiber network, which you can see in the circle top left, and which helps to extend our reach all the way into the Nordic countries.
What is
is there a question?
Yes. What is spectrum? Is it a wireless technology, or what is it?
No, it's part of a fiber. You only get some of the wavelengths in the fiber.
Wavelength multiplication. Color multiplication.
So you can in a fiber you can have you can run your bandwidth over various wavelengths. Nowadays you can have up to 200 wavelengths in a fiber easily, and we, for all the bandwidth we have, we don't usually need the full fiber. So sometimes it's cheaper to get just a couple of wavelengths in there, which we can dedicate to various services. The red part is in those areas, it's not economically feasible to get fiber. It's just way too expensive to get fiber to all the way to Malta, Cyprus, and Israel. So we work with 100 gigabits per second leased lines in those areas. And internationally, we also have expanded, as you can see. We now have multiple connections into various parts of the world, several of them at 100 gigabits per second. Especially, I'd like to point out our connectivity into Asia. We have redundant connectivity into China. We have 100 gig into Japan. We have 100 gig through Singapore all the way into Australia. And that is also in preparation of the square kilometer array project that is run over there. The same goes for South Africa, where we are building out now from 10 gigabits to 100 gigabits to also be able to support the square kilometer array when it gets operational in that area. We have plenty of connectivity into the Arabic Peninsula, and we have lots of connectivity into North America, especially to the United States. As you can imagine, we have multiple links there running across the ocean. It shows only one line, but I rest assured it's multiple lines, so that if one of them gets bitten by a shark, all the other lines continue to operate. And we are directly going into Internet 2 in the United States, but also into the energy science network that is very keen to have multiple 100 gigs connections into CERN through our network. The one I'm most proud of is the link through Latin America. There was no, until a couple of years ago, there was no real data link available between Europe and Latin America. All the traffic was always running through North America. But as you can imagine, that at some point in time, with all the revelations by Snowden, the European and the Latin American governments were no longer very keen on having all that data snooped in the United States. So they really wanted a direct connection between Europe and Latin America. And both of them put financing together, and they asked CERN to be the launching customer for that. So we were tasked by getting a commercial consortium together and being the launching customer for that connection. And this worked. Ella Link was the commercial operator that was put together, and they managed to get the link in place, and it was operational last year. And we are now having, CERN now has multiple fibers between Europe, Portugal, and Fortaleza in Brazil. So we can serve especially the Earth observation that is having several radio telescopes in Latin America, from which they have multiple data sets that they want to transport into Europe. So why would you need a specific research and education network? Why couldn't you deal with the standard telecom network? Well, to look at that, a couple of years ago, we did a test from CERN all the way to Australia, to Canberra. And we transferred 100 terabyte data file. And we did it over 3 different connections. We did it over a connection by the research and education networks at 10 gigabits per second. We did it over a commercial connection number 1 with 10 gigabits per second, and we did it over commercial connection number 2 with 10 gigabits per second. In the top left, you'll see the results we got from the first commercial provider. We played around with the buffer size, but on average, we got something between 1 and 2 gigabits per second while we were paying for 10 gigabits per second. With commercial operator number 2, left bottom, it was even worse. We got on average 0.1 gigabits per second out of that 10 gigabits for which we were paying. And on the top right, you see the performance we got out of the research network infrastructure using the CERN infrastructure and other research infrastructures all the way into Australia. You see we've got on average 9.27 gigabits per second. And by now, as I just showed, we don't have 10 gigabits, we have 100 gigabit all the way to Australia. So now the performance would be 10 times as good, I might say. And the difference is because of the different patterns in traffic. On the top, you see a typical traffic on a commercial network. You can easily recognize the day and night pattern, and you can easily recognize the 5 working days, various 2 lower peaks, which are the weekend. So you have a very regular pattern, and as you can see, the amount of traffic goes up to roughly 25 gigabits maximum, maybe one peak that almost reaches 30 gigabits per second. At the bottom, we look at the LHC1 ingress to our network, and as you can see, there's no discernible pattern there. And on top of that, you have peaks that go all the way up to 800 gigabits per second. So this requires different engineering. With the commercial network, you can do a lot of tricks like move content around in the weekends or at the nights when the network is less used, and therefore you have content close to content delivery networks which are close to the edge of the network, and which take away a lot of the traffic on your network, and therefore you can dimension your network in a very different way. You can't do that with research and education networks, and this is why you need them. The traffic growth is enormous. We double our traffic roughly every 3 years. And you can see that when the pandemic started, our traffic dropped a little bit because people were starting to work from home. But as you can also see, it soon got back up again and is following the same line again in growth. And you can also see this graph was from last year. And if you can, this is the LHC1 ingress again, and you can see that while at the start of the year it was around 100 to 150. By the end of the year, we were reaching towards the 300. So it almost doubled in a year there. A little bit about the services. Most research and education networks at the national level run their own services, but in a lot of services they get from GEA at the European level, and they brand it in their own way. They brand it through their national wishes, and then move it on to research institutes and to universities, etc. At the network level, we run, of course, an internet protocol service, but we also run what we call a Lambda service, where you can get a dedicated connection if you need it, which is not using the generic IP network. This is, for example, done for LHC1. We build a separate network for that, so that the traffic coming out of the Large Hadron Collider is not disturbed by students watching cat videos. And we do on the network support, we deliver various services like Wi-Fi monitoring or performance sonars, which measure the performance continuously in the network, so you get early warnings when something is wrong. We offer security services like firewall on demand and DDoS cleaning. So if there's a large DDoS attack, denial of service attack, on one of the institutes or one of the national research and education networks, we can reroute the traffic through a specific set of machines that will clean out all the false traffic and leave all the good traffic in place and reach its destination. We have several services which start with Edu VPN, which allows you to set up a VPN wherever you are to avoid unsecure Wi-Fi networks, allowing people to hack into your laptops. And you can end the Edu VPN wherever you want, in your own institute or in one of the national research and education networks. So you can also use it to bypass geo-blocking. We got EduRoam, which I hope you all know, which is one of our most popular services, which allows you to roam through Wi-Fi all over the world. If you're in an institute for research or education anywhere in the world, you open up your laptop and you can work with your home password and user ID. The system beneath that is called EduGain. That's the federated identity system, and it's used not only for EduRoam, but it's also used to give you access to various cloud services, etc. So on and on, we have services also in the cloud. We don't deliver our own cloud services. What we do is we collect all the demand from all institutes and networks around Europe. We combine them into one European tender, and then we do a procurement for IaaS services in the commercial world, and we get framework agreements so that once these are in place, institutes like CERN don't have to do their own European procurement anymore. They can just subscribe to that framework for that. So the EduGain, the federated identity, is available in 70+ countries. Over 4,400 institutes are using it to access over 3,400 different services. And EduRoam the seamless Wi-Fi roaming is available in 106 countries with over 8,000 institutes and over 32,000 Wi-Fi locations in the world. As for the procurement, like I said, what we do is we aggregate the demand from the various countries, and countries can, National Research and Education Network can subscribe on behalf of their local institutes. And we have 36 in the last one, which is called Okra, which we did amongst others together with CERN, by the way. We have 36 participating countries where research and education institutes act as a single digital market. We got 1,100 bits to our cloud procurement, and in the end, we had 473 different cloud contracts, which represent 27 cloud platforms in all the different countries with suppliers in all the different countries. We tested the whole platform using the Helix Nebula Science Cloud with the help from CERN to make sure that all of this worked. So this avoids an enormous amount of institutes in Europe to having to do European procurement themselves. And of course, the buying power, but also the negotiation power when you aggregate that market is a lot bigger. So you can have better demands on where the data is stored, how the data is stored, GDPR issues, etc., as well as the price, of course. Last but not least, I'd like to point out is one of the big things that research and education networks are very keen on is building community support. So I think that the community support is just as important as all the services and is just as important as the network itself. We invest in bringing our community together, in bringing people together such that if a researcher in Turkey has a problem communicating with a researcher at CERN, that we can immediately act on that because we know each other, we have the community, and we know who to phone, who to email, etc., and make sure that we can give a kind of a personal service to make sure that that works. And one of my favorite examples in that is when somebody from a university in the US in Austin, Texas, they wanted to communicate with an archaeologist, a professor who was doing a dig in Turkey, and they could not understand how they could connect those together in a good way. And when they asked Internet 2, it was arranged pretty fast. Internet 2 connected us. We know the people in Ulakbim, the Turkish network, and the people in Ulakbim knew the closest institute towards the archaeological dig. And within a couple of days, we had set up a very reliable high-speed connection between the archaeological site and the University of Austin in Texas. Those are the things that the community arranges. Community also innovates constantly to address the new needs of scientists and researchers and to be able to deal with that. And therefore, you get a specific set of services that you will not find in the commercial world. The biggest focal point for our community support is our network, which is called TNC, our conference that's called TNC. TNC before the pandemic was drawing 800 to 1,000 people per year. Of course, during the pandemic, we had to move online, so that you can't compare that, but we still had over 1,000 participants online. This year, it's going to be hopefully real live again in Italy, in Trieste in June. And we are expecting hopefully over 500 people again. We do realize that intercontinental travel is not gearing up yet, so we don't expect our participants from outside of Europe to be there, but at least from Europe, we hope everybody will be there. We run special interest and task forces, and we run research programs and service development, and we create a talent pool, because getting people in IT is difficult enough, as you are probably aware. So at the international level, so at the GEA level, at the national level, of course, research and education networks work together with their institutes. But at the international level, we work with all the international institutes from GEA and in the various areas, in the astronomy, physics, and you see CERN there all the way on the left, and Earth observation, of course. We work with the various parties like ESA, etc. And we work with other e-infrastructures. We work with life sciences. We work with the arts and humanities, and so on. So we also try to be an interface for real international organizations that have international needs, and to make sure that we address those. That was the present. Now a short look into the future, and this is a European perspective into the future. We are talking at GEA currently about the Big Five, in analogy with the African Big Five. And I'd like to briefly address each of these. One of those is the GEA project. One of those is the European Open Science Cloud, the ambition of the European Commission to get to a European open science program. We have the European High Performance Computing Program, also very ambitious. We got the Quantum Communication Program, and we got the Intercontinental Autonomous Connectivity Program. So briefly look at those. Our fifth instantiation of the GEA project is almost ready to start. We'll start with that in 2023. It's based on previous instantiations of the GEA project, grown over more than 20 years. We constantly rate excellent in reviews, and it's based on an 8-year partnership agreement with the European Commission, a so-called framework partnership agreement. The fifth instantiation will mainly focus on security, trust, and identity, while the network is hopefully growing towards 1 terabit per second in that time frame. And we're talking here 2023 to 2027, that time frame. If we look at the European Open Science Cloud, I like to compare that to the elephant. And all the blindfolded people who touch the elephant all have their own idea of what it is. It's a rope, it's a wall, it's a tree, it's a snake, a spear, or a fan. None of them have the same idea. And that's exactly what is with the European Open Science Cloud. Whoever I speak about the European Open Science Cloud has a very clear picture of what it is. Nobody I speak to has the same picture as anybody else. And that makes it really difficult. Some people see it as the opportunity to build a European cloud program to stimulate European cloud industry. I think that ship has sailed, so that is an illusion to build a European cloud industry. Some other people think it's the best way to promote open science, top down. It may work. We will certainly, we are committed to make it work, but I think we really need to see whether it also grows bottom up, because scientists are very peculiar in what they want to do, and if it isn't easy, and if it requires a lot of hustle, it's not going to work, of course. So this is a real big challenge to make that European Open Science Cloud work, and fortunately, there's now an association that will focus on it, and in that the individual scientific institutes are represented, and I have more faith in that that through that way it might work, and we'll get this vision more harmonized. The third one is Euro HPC, the European ambition to build a next generation high performance computing all through Europe. That requires, of course, and that's my perspective, that requires terabit per second connectivity a lot earlier than other research efforts will require that. So we will have to look in how we can provide that at the European scale, how we can provide that network earlier than the demand from other institutes will justify that, and how that will be financed. Quantum is the most far out technology, but it's the technology that is, of course, having a lot of attention, and we are working with the quantum community to build test networks and to see how we can get quantum communication over longer distances. This is still in the early stages, but it is something that is fascinating, and I believe will in the end set the standard for a new level of secure communication in the world. The funding environment for that is still not very clear, so I hope that that there will be stable funding and we can develop this at a faster pace in the near future. And last but not least, that's the international, or rather you should read intercontinental part. That's the submarine cables going out of Europe to the rest of the world. Most of these cables nowadays are owned by commercial entities, and usually by the big platforms like Google, Amazon, Microsoft, etc. They have such deep pockets that for them putting in or buying submarine cables is a non-issue, while for research and education it's a huge investment. And the European Commission has now found out that Europe is not involved almost in any of these submarine cables except for the one to South America that I talked about earlier, which was our own initiative. But otherwise, all the other cables running towards or from Europe are owned by non-European entities, and that makes Europe very, very dependent on non-European entities. So this realization has reached the political level, and because of the wish for autonomy, there is now more money available to invest into submarine cables that will be more European owned, and we hope to profit from that for the research and education community, in the sense that we can be a launching customer in a lot of those initiatives, and therefore get a lot of capacity on those cables that we can use for experiments between Europe and other regions in the world. And with that, I think I hope I've given an overview of the history, the present, and the future of research and education networking. And the floor is open for questions.
Many thanks, Eric, for this nice lecture. So then I'm going to check if there are raised hands, or if not, I will go directly with the chat. So yeah, I will go directly with the chat. So from Igor, was there any collaboration, interconnection, relationships of GN with commercial networks, and what was mutual influence between research and commercial networks?
Yes, there's continuous interaction, because the network I showed you that we run inside Europe as well as to the rest of the world, we don't actually own the fibers. We kind of rent or lease the fibers. And to do that, we put out a procurement in the commercial market. And we say we want dark fiber from there to there. And by pushing that procurement demand into the market, we stimulate the market. But vice versa, the signals we get from the market, from the commercials, we use to build our ideas for new places where we want our fibers or we want our services. And in the end, we procure most of it, and therefore our interaction with commercial parties is usually it ends in a procurement level in that sense. That is a continuous interaction between the market and our procurement, which is a demand stimulation. So in that interaction, we grow the international telecoms market as well as the international research and education market.
Sorry. Okay, thank you. So then from Veronique, she was writing me a direct message. So who pays for the fiber installation and maintenance?
Sorry, I didn't get that one.
Yes, Veronique was asking who pays for the fiber installation and maintenance.
Okay, so we rent the fiber for, or lease the fiber for 15 or 30 years. So it's a long-term, irrefutable right of use. That includes maintenance at the fiber level. So the company we rent it from is responsible if there's a break in the fiber, they have to repair that. We put our own equipment to light the fiber. So we have our own equipment at both ends that will light the fiber, that will decide on the wavelengths to use, etc. So we use that to if something breaks there, that will be our own cost and our own. The financing of Géant and most NRENs is dual based. Once about 50% of our income is due to projects we run for the European Union. So 50% is financed by the European Union, and 50% of our funding comes from our members. So our members pay for our services. That means that the 40 members in the 40 countries pay half of our turnover to allow us to serve them with our network and our services.
Okay, very clear. So I got a question from Maria Di Mo, and I think she wanted to say, Maria?
Sorry, I just wanted to ask if, Eric, you say the boat of the hope to make a European cloud has already sailed and it's an illusion. How do you feel so optimistic about the quantum network communication on which you say work is starting? Why would we have a better fate there?
Because there it isn't dominated yet by really large platforms, while the cloud industry is dominated by the really large platforms which have such deep pockets that whatever you try to build in Europe, as soon as it's successful, they will buy it, and therefore it will never become a European cloud industry really. While with quantum we're at the start, and there's companies formed in the US but also in Europe, and there's no clear way to distinguish there who's going to be successful and where that will develop. Although I'm a bit afraid that once something is really successful, the deep pockets of Apple or Google, etc., might still buy it and they move into quantum as well. So you might be pessimistic there, but I think at least we stand more of a chance than in the fully established cloud market.
Thank you.
Okay.
Maria, if you allow me, I'd like to react to Romein's comment.
Yes.
Romain finds it detrimental to the whole community that geopolitics can bear so much influence on GEA. Yeah, so I can understand that, but I think we're doing pretty well. We have kept our communication with Russia intact. We still peer with Russia. We still support communication to Belarus. So our principle is to keep communication alive as long as possible and not to let that be influenced. However, at the project level, so specific projects like LHC1 and the EAP Connect project, there we cannot allow the cooperation with entities like Russia and Belarus to continue in the current environment. So that's where we ended those cooperations, but we kept the communication, we kept the peering with Russia, and we kept the connection with Belarus alive. So I think we're doing a pretty good job, not just blindly following geopolitical developments.
I'm agree with that, but I can see Roman that would like to comment something.
Yeah, just as a quick comment. So of course, this is an unprecedented situation, which was not taken into account when the whole thing was designed. But I think in the long run, would it be worth designing the project structure so that you can have more neutrality in such circumstances in the future? Like you cannot take down the internet because it's designed to be resilient for so many kind of risks. And maybe it would be nice if GEA could be designed in such a way that regardless of the geopolitical situation, you cannot impede on communication and you maintain net neutrality status, which is precious for many of us in the community. I don't know, it's just my opinion. I don't mean to start
no, I see where you're going, and that would be ideal if we can do that. But we are a membership organization, and that means that and several of my members are part of a government, and that automatically means that at some point in time, if things get really, really shitty, then you'll be influenced by politics as much as I wouldn't like that. I'm very much with you. I wish we could just neutrally keep the communication flowing as much as possible. If only for the fact that allows researchers in Russia and Belarus to communicate with their peers and get some facts and figures in a way that their state-owned media won't allow them to have.
Thank you.
Thank you very much. So is 1 minute left, maybe just the last question. Related question from Remy. Is there some network guide policy on censorship, example, websites or internet services in GEANT?
No, we don't block anything at GEANT. So despite the fact that the European Union now has declared a law that you should be blocking Russia Today and Sputnik, this is happening by national research and education networks. Not all of them, but some of them are forced to block that. GEANT is not blocking it. We are letting through anything that we can. However, our upstream providers might be blocking that. So even if you try getting, but we don't do any filtering at GEANT. We refuse to do that. Again, for the same arguments that Romain just made, we want to be as neutral as possible there. So we won't be doing any filtering. So our acceptable use policy at the moment is that we don't do any filtering. I must add, there's of course one exception to that, which I described earlier, which is the DDoS filtering. So if there's a denial of service attack, we filter out the bad packets. And you might say that violates our own neutrality policy. but then you get into a very difficult debate at that point in time.
Yes. So thanks a lot, Eric, for even this last clarification and so on. It was very good. And thanks to all of, and thanks of course for the lecture, and thanks to all of you of joining, because we were doing this change of timing, but we were reaching 163 participants, which was great. So thank you very much, so all of you, for this success lecture.
It was my pleasure. Thanks for inviting me. And if anybody has any questions left, just email me. Thank you very much.
Thanks.
Thank you. Bye-bye.
Bye. Have a nice day. Ciao.
Bye-bye.